given a circle with perpendicular lines B, C, D, E. So B, C is perpendicular to D, E. As you guys know, it means that they intersect at 90 degrees. FA is 6. So right here, I'm going to grab a different ruler. Hold on. Right, and then AC here is 10. So we're supposed to find BF right here, right? So if we know A here is this midpoint, so we know that the radius, does it actually say that? Well, this is the radius is 10. So if this is the midpoint, and here's one radius, then we know that the length from A to B is 10, right? So we can go ahead and write that down. A, B is equal to 10. So therefore BF is 6, which is 4. Pretty simple there. And for your explanation, you write what I was saying about the radius and all that. All right, so now let's move on to the exercises. That was a pretty simple warm-up, which is nice. Get your brains working. Where is it? Okay. So for this first one, given circle A with the measure of arc BC here, it's folded, is 54, and CDB, so let's use our highlighters again. CDB right here is congruent to DBE. Where is that? DBE. Okay. Find the measure of these is equal. We know that we're looking at two lines that are, let's see, they should have equal segments in between them, right? So take a second to think about this. What do you think measure of DE is? What do you think? Well, we know that because these measures have the same thing, it's like when you're looking at parallel lines cut with the transversal. These here have the same measure as this guy here. So the measure, and it's a minor arc, right? It's denoted only by 2 characters and it's smaller than 180 degrees, is going to equal 54 degrees. A couple of other things that we notice here that I'm going to go over. We learned this last time, but let's go ahead and go over some key points. So another key point would be that the CD, that's the angle, also equal to 54, because the measure of an inscribed angle is always the same as the measure of the arc. Let's see, is there anything else that we know from this? Maybe the measure of CDB. So let's see, so it has the same 2 endpoints as the arc, but it goes to the other side. So if you remember, that's called an inscribed angle. Inscribed angle, CEB, equals, it's going to be 27 degrees because it's always 54. Right? Yep. So those are our key points there. Measure of DE equals 54 degrees. Okay, let's go. Looks like we're still online, that's good. Let's go to exercise 2. Alright, if 2 arcs in a circle have the same measure, what do you say about the quadrilateral formed by the 4 endpoints? So we can actually, I'm going to go back to this diagram, or, you know, I can draw one. Sorry, don't mean to move it around too much. Grab my compass. Okay. Okay, so we have here the compass. And I'm going to go ahead and go through the midpoint, which you don't have to do, but I will just for this one. So we know since these vertical angles, right? Vertical angles are congruent. They're the arcs have the same measure. So we have these two arcs here that are equal. Let's go ahead and call this point A, B, C, D. We'll say the measure of AB equals the measure of CB. So what can you say about the quadrilateral formed by the endpoints? So quadrilateral, so let's connect this. What do we know about this guy? It's a quadrilateral because it has 4 sides, right? What do you think we know about it? Take a second to think about it. Well, a couple things. We know it's symmetrical. We know all corresponding angles will be equal in measure. Okay. So if we have congruent arcs, their endpoints can be joined to form chords, okay? So the endpoints of arcs are joined to form chords that are parallel. So we can see that here, right? AC is parallel to BB. See? All right. The chords subtending congruent arcs are also congruent. So that means these here are congruent. You know that, they're the same length. So AB is congruent to CD. And a quadrilateral with one pair of opposite sides parallel and the other pair of sides congruent is an isosceles trapezoid. So that's what this is called. So I think that's a new definition. So a quadrilateral with opposite sides parallel and other opposite sides congruent is called an isosceles. I'm drawing a blank. Trapezoid, there we go. It's called an isosceles trapezoid. All right, for number 3, scoot down a little, you should be able to see number 2 still. Find the angle measure of arc CD and EB. Okay, so CD and ED. How do we find the angle of those, the measure of those arcs, when we know this one here? Take a second to think about how we'll go about this. This is an exercise, so if you're not watching it live, I would pause the video to think about it. Grab my calculator here.
Mom, I'm hungry. Mom, you're gonna make me one time to open me over. Mom.
Alright, stand by while I take a message from our sponsor. Don't have done with my video yet. Can you wait? I'll make you hot water.
I'm gonna open me
That's what
over.
I'm doing here. Come up here. Your bowl's here already. Actually, no, it's not. Alright, sorry about the interruption. So let's check it out. So what we know is that we have the measure angle EDB, and we know since these are parallel lines cut by a transversal, that this angle is also 65 degrees. And if you note, right, so if we were to look at this, this would be considered a central angle, right? A central angle corresponds to arc CD. Central angle. Okay, so central angle corresponds to arc CD. So a central angle is always twice the length of an inscribed angle. So CD is equal to 2 times our inscribed angle, 130 degrees. Okay, so now how do we find ED knowing that? Well, since these are parallel lines, we know that this would be extended through here, right? So, what's the measure of this angle?
I put my team.
I saw that, but use that napkin to clean it up, please. And put it on the table. Don't have your drink on your chair. Sorry. Okay. Let me see real quick.
Mom, I want you to see today. Mom, what's that today?
Cool. Alright, so what we know from our last exercise is that these intersect, they're perpendicular. So here we have a 90-degree angle, right? And if you look, we have a triangle. So if this is 65 and this is 90, this angle here must be 25, right? And again, we go by that logic. We have a central angle here. These are all congruent. So this one's also 25, 65. If it helps you to label all of it. Just checking something, seeing if I'm backwards here. I think I am backwards. Measure of angle. Well, I guess the other way to look at it, I'm looking at something wrong here, but I know, so we know that this angle here, we know that this arc is 130 degrees. Did I get these? I think I might have got these backwards. Just give me 1 second. ED. Okay. Well, we know that this is 180 or 130, and we know that this whole thing from C all the way to E is 180. So therefore, CD must be 180 minus 130. So ED is equal to 50 degrees. Yep. And then we also know because the inscribed angle is 25, it's going to be twice that value. So now I'm looking at something wrong here, but that is correct. So we, one way, I know that it's not 65, so something's going on with the way I wrote the corresponding angles. Or just the way I'm looking at it, I'm seeing something. But I do know I can look at this as a 180-degree arc because it's half of a circle. We know for sure that this one's 130, so 180 minus 130 is 50 degrees. So there's always more than one way to look at these things. Every once in a while, you can get yourself a little twisted up, and then it's hard to see it correct. So if you're doing that, just try and take a different perspective on it, and that can really help. Alright, so we now have the measure of arc CB equals the measure of arc ED, CB, ED. So we'll go ahead and CB equals ED. Let's put this over a little bit more. BC to BD to EC is a 1 to 2 to 4. So find the following angle measures. Okay? You can do that. Alright, so let's think about the ratios here. BC to BD. So this here to this is 1 to 2. And then BD to EC better put your oatmeal in, bud. Not all your hot lava. Put your oatmeal in before it gets cold. Alright, sorry. Okay, and then we have BD to E. Here we go. BD to EC, that goes all the way around here, is a 2 to 4. So it looks like the measure of angle BCF, let's see, BCF here, what is this? Well, 1 to 2, and it goes through the middle. We know that this would go through the middle, right? Because they're congruent. So we know that whatever this is, it's going to be half of a central angle that goes through 90 degrees. It intersects it at both half points. So what would an inscribed angle be from 90 degrees? Well, it'd be half of that, which would be 45. Okay? So half of that would be 45. Right, we're looking at this. And this is an inscribed angle with the same endpoints. This is double. It's a 1 to 2 ratio. Make it 90. And then 2 to 4. Which... 2 to 4 would double it again, and looking at the answer that's given, I don't believe that's correct. A 2 to 4 would make this double again, right? Because 2 to 4 is the same as 1 to 2, and it does look like it goes exactly halfway through. So the measure of angle CF I see. CFE. Here. That's why they're doing that. Okay. So CFE is going to be what's remaining. It's over here. So we know that EC here has the ratio of 4, which would make it 180. And since it's half the circle, that would make this angle also 180. Oh, look at this. I don't know if this is drawn to scale. Let's find out. No, it can't be 180. Sorry, it's not 180 because it's not a straight line. I'm being silly. Oh, no. So we have 45 here. We have EDF. Hold on. BCF. Okay. And then we have EDF. Is this 90? I'm going to label these EDF 90, B would be CF here, 45. Okay, makes sense because the arc, it's a 45, 45, 90 triangle. So what other angles do we know? We know this is 45, this is 45. So if this is 45 here, we're left with this. There we go. That's what I needed to get the angle. And this over here would be 180 minus 45, which is what? 135. Just check it. Perfect. That one took some looking at too. I was looking at the wrong angle at first, so I was thrown off. Got there. Alright, this is the last example in this lesson. Alright, BC, right here. BC is the diameter of a circle, A. BD to DE to EC is a 1 to 3, and a 3 to 5 ratio. Find the following arc measures. What's the measure of BD? Ah, okay. Well, we know the total measure of all the angles is going to be 180, right? Because it's a diameter. So we know the total measure of all of those angles is going to be 180. And now we have to find the ratio of 1 to 3 to 5 that fits in to 180. Okay? So let's think about this. Plug some things into my calculator here. All right. Whoop. So we can write out some ratios. So we know, I guess I'll come up here. BD over BE equals 1 over 3. Okay. And then DE to EC. Oops, sorry, this should be a D. And then DE to EC should be 3 to 5. And then what's the other one they're looking for? ECB, which we can find after we find this last angle here. DEC. Okay. What else do we know? So we know between these three angles, so let's see, 1 to 3, 3 to 5. So that means that there's 9 total parts between these angles. So that means that the first segment here is 1/9 of this whole, sorry, binder got in my way. So this little thing here is 1/9 of 180. Okay? So 180 divided by 9 equals 20 degrees. So that's how we got our first one, because there's 5, 6, 7, 8, 9 parts in this entire ratio, and BC is the diameter. So since there's 9 parts, you divide the diameter by 9 to get our 1 ratio. So now we know that this here, right? Let's see. Well, we know BD to DE is 1 to 3. So what are we trying to find here? DEC. I think I'm trying to do more than I need to do here. Here. So now we're looking for this measure of arc DEC. Okay. So we know that this little fragment here is 3 times bigger than this one. So it would be, so DE would be 3 times 20, which equals 60. And then we know the next one's a 3 to 5 ratio, which means, or you can look at it like a 1 to 5 from the beginning. I think that's a little easier to look at just because then you multiply it straight by 5. So let's go ahead and look at BD, and this right here is BD. Okay, so if we look at BD as a 1 to 5 ratio, then we can look at it as BD, which was 20 degrees times 5, which is equal to 100 degrees. So EC here is 100 degrees. So here we have, I'll label it in here. So 60, 100. That means the measure of DEC is 160 degrees. We know this one here is 20. Okay, so then what's the measure of, I'm getting a new color here, ECB. ECB here. Well, we know that BC is the diameter, right? So that's 180 plus 100 would be equal to 280 degrees. That's it. We've finished the lesson. If you have any questions, feel free to comment, and I'll get back to you as soon as I can. And thanks for watching.